Cobra maneuver physics, the hidden risks. You have probably seen it before. A fighter jet screams across the sky, suddenly pitches up to an impossible angle, almost stops in midair, and then recovers like nothing happened. It looks unreal. Almost like the aircraft just broke physics. This is the Cobra maneuver. For decades, it has been one of the most iconic displays of extreme aircraft control. But here is the question almost nobody asks. What actually happens to the aircraft and the pilot during this maneuver? And why is it almost never used in regular flight operations or real mission scenarios? Behind the spectacle, there is a very different story. At first glance, the Cobra maneuver looks like an impressive tactical move. The idea seems simple. You force an overshoot. Another aircraft flies past you. You gain a different position. Sounds smart, but that is only the surface. To understand why this maneuver is controversial, we need to talk about something far more important than angles or visuals. We need to talk about energy. Every aircraft in flight is constantly managing energy. Not just speed, but a combination of velocity, altitude, engine thrust, and aerodynamic efficiency. In high-performance aviation, energy is everything. It determines who can climb, who can accelerate, who can extend the flight path, and ultimately, who maintains control. Now here is the key point. The Cobra maneuver deliberately destroys that energy. During the maneuver, the aircraft rapidly pitches up to a very high angle of attack. In simple terms, the nose points up sharply, while the aircraft still has forward momentum. But this creates a massive problem. At these extreme angles, the airflow over the wings breaks down. Lift drops dramatically. Drag skyrockets. The aircraft essentially trades almost all of its forward speed for a brief moment of dramatic positioning. It looks controlled, but aerodynamically it is extremely inefficient. In fact, during a Cobra, the aircraft is very close to a deep stall condition. This is not normal flight. This is the edge of control. Modern aircraft can recover from it because of advanced flight control systems, thrust vectoring, and careful design. But recovery is not instant, and more importantly, it comes at a cost. Speed is gone, energy is gone. For a few critical seconds, the aircraft has very limited maneuvering options. Now imagine this, not at an air show, but in a demanding operational environment. You perform a Cobra. Your speed drops drastically. Your ability to change direction or climb rapidly is reduced, and the other aircraft is not forced to fly straight past you. Real aviation is not a scripted duel. It is dynamic, unpredictable, and often involves multiple aircraft and complex situations. This brings us to one of the biggest misconceptions. The Cobra is often presented as a dogfight trick. But modern high-performance flying rarely looks like classic dogfighting. Instead, it is dominated by long-range detection, sensor sharing, coordinated flight, and energy management. In this environment, bleeding off energy is usually the last thing you want to do. Let us talk about the pilot, because the aircraft is only half the story. During extreme maneuvers, the human body becomes a limiting factor. High angles of attack and rapid pitch changes can produce significant G-forces and spatial disorientation. Even if the maneuver itself is brief, the transition phases can stress the pilot. There is also a cognitive factor. Flying already demands situational awareness, rapid decision-making, and constant evaluation of the flight path. Introducing a maneuver that temporarily destabilizes the aircraft and disrupts energy flow adds complexity at the worst possible moment. Now to be clear, the Cobra maneuver is not useless. It demonstrates something very important. It proves that the aircraft has high controllability at extreme angles, strong flight control systems, and the ability to recover from unstable conditions. These are valuable engineering achievements, but demonstration is not the same as application. Just because something is possible does not mean it is optimal. There are very specific, limited scenarios where high angle of attack maneuvers could have niche value. For example, very close-range encounters, specific positional setups, or as a last resort defensive move. But these are exceptions, not the rule. And even in those cases, the risks remain. Now let us connect this to modern fighter design philosophy. Today's aircraft are not optimized for flashy maneuvers. They are optimized for survivability, information advantage, and controlled energy management. The goal is not to impress. The goal is to maintain the highest level of control throughout the entire flight. This is why many modern training doctrines emphasize maintaining speed, controlling engagement distance, and avoiding unnecessary energy loss. Because once you lose energy, you lose options. And in demanding flight conditions, options are everything. There is also another layer to this. Modern flight systems and advanced sensors reduce the need for extreme positioning. Instead of forcing an overshoot, a pilot can reposition using energy-efficient turns, use onboard sensors, or rely on coordinated flight with other aircraft, which again makes energy preservation more valuable than sudden dramatic movements. So why does the Cobra still get so much attention? Because it is visual. It is dramatic. It looks like control over chaos. At air shows, that is exactly the point. It showcases engineering capability in a way that is easy to understand. But real-world operations are not about visuals. They are about outcomes. When you analyze the Cobra maneuver from a purely physical and aerodynamic perspective, a pattern becomes clear. It trades long-term advantage for short-term spectacle. It sacrifices energy for a brief moment of unusual positioning. And it introduces reduced controllability in exchange for a moment of surprise. In controlled environments like air shows, that is impressive. In demanding real-world flight, that is risky. This does not mean pilots avoid high-performance maneuvers. Far from it. Modern aircraft are incredibly agile. But agility is used strategically, not theatrically. The real skill is not in pulling the most extreme maneuver. It is in knowing when not to. Because the best pilots are not trying to prove what their aircraft can do. They are focused on maintaining control, awareness, and energy throughout the entire flight. And that brings us back to the core idea. The Cobra maneuver is not about breaking physics. It is about pushing the limits of physics. And those limits come with consequences. So the next time you see a jet perform a Cobra, remember this. You are not just watching a cool trick. You are watching a demonstration of control at the edge of aerodynamic stability. A moment where the aircraft briefly steps outside efficient flight and then recovers. It is impressive. It is technically fascinating, but it is also a reminder. In aviation, especially in high-performance aviation, efficiency and control beat spectacle. Thank you for listening.